Welcome to the training course on IBM Scalable Architecture for Financial Reporting, or SAFR. This is Module 18, Extract Time Summarization and Other Functions. Upon completion of this module, you should be able to describe uses for the extract phase record aggregation, formerly known as extract time summarization function, read a logic table and trace extract time summarization views, describe how other SAFR functions affect the logic table, explain the function codes used in the example, debug ETS and other function views. The prior modules covered the function codes highlighted in blue. Those to be covered in this module are highlighted in yellow. In the prior module, we learned how the format phase engine creates summarized outputs. Except for producing standard extract file format records, the extract engine typically plays no role in summarization. The one exception is extract time summarization, or ETS. With extract time summarization, some level of summarization occurs at extract time. This can have significant benefits if the final summarized output file is relatively small, but the number of event records required to produce it is very large. This reduces the I/O required to write all of the detailed extract records, and then for the sort utility to read all those records again. This is a common problem where high-level summaries are required for initial analysis of results before investigating greater detail. Use of ETS is specified in the View Properties pane, Extract Record Phase Aggregation parameter. The View developer specifies the use of extract time summarization. They also specify how many summarized sort keys the extract engine should hold in memory during extract time. Only the sort keys for records held in this buffer at any one time are eligible for summarization. Specifying a large number of records may result in greater summarization during the extract phase. However, the extract engine allocates memory equal to the number of records multiplied by the number of bytes in each extract record, multiplied by the number of input partitions of the view reads during parallel processing mode. If large numbers or buffers are specified or many views use ETS, the extract engine may require substantial amounts of memory. Although ETS collapses some records, complete record aggregation is only assured in the format phase. ETS may still result in duplicative records, depending on the order of the input records, because the keys required may overflow the ETS buffer. If the total number of output keys exceeds the buffer size, the extract engine will dump the records with the least used keys to the extract file. In this example, the ETS record buffer is set to 3 records. However, the total number of output records in the final file will be 4. Because of the order of the input records, the extract file will contain 2 records with the same key. After the extract process, the sort process as part of the format phase places all duplicate keyed records next to each other. Thus, no matter the number of duplicate keys in the extract file, all to be eliminated during the extract phase process. In the example on the left, ETS buffer is set to 3, and 2 records with the key AAA111 are written to the extract file. In the format phase, these records are summarized together. If the ETS buffer had been set to 5, memory would have been allocated but never used. If the ETS buffer had been set to 4, no memory would have been wasted, and no unnecessary I/O would have been required. Consider the following when setting the ETS buffer size: the total number of summarized keys in the output file. ETS is often used for thousands and even tens of thousands of rows. However, it's typically not used for hundreds or hundreds of thousands of rows or more. The sort order of the input file. If the sort fields for the views are the same as the sort order of the input event file, then a buffer size of 1 will result in no duplicates in the extract file. This is because once a row is dumped to the extract file, the same key will not appear again in the input file. The extract phase memory available, which will be impacted by the number of views executing in this extract phase, the memory required for reference tables being joined to by those views, ETS buffer sizes specified in other views, other items such as the size of the logic table, buffer sizes for input and output files, and common key buffering. Similar to the format phase, ETS only acts upon CT column data for records with the same sort key values. However, unlike format phase processing with multiple column calculations possible, ETS only performs summarization. Multiplication and division of values is not possible with ETS. Also similar to format phase processing, resulting DT values are unpredictable. In this example, the ETS extract file output is only 2 records, one for F and one for M. The CT packed values are accumulated to produce the accumulated results. Although standard extract file format is typically used to send data to the format phase, logical records can be constructed to read a specific view extract records for additional processing. The ETS output records are often used with Saffer piping to produce records processed in downstream threads. Piping will be discussed in a later module. The only change to the logic table when ETS is used is that the WRXT write extract record function is changed to a WRSU write summarized record function. Although a WRXT row can only write one record to the extract file, a WRSU function may write an extract record to the ETS buffer and also a separate overflow record to the extract file if the buffer has overflowed. At the conclusion of extract phase processing, all remaining records in the buffer will be dumped to the extract file. These additional write functions are not shown in the logic table trace. The logic table trace only shows this function once, even though no record or multiple records may have been written to the extract file. Next, we'll examine additional logic text keyword functions and how they impact the logic table. Saffer logic text keywords often manipulate the constant portions of a CFEC or CFLC compare field function. For example, the batch date keyword creates a constant of the execution date. Thus, the logic text select if order date less than batch date that is run on January 3, 2010 creates a CFEC comparing order date to the constant of 2010-0103. Many of the keywords allow math. For example, if the batch date contains a +3 inside the parentheses and were run on the same date that the constant would be 2010-0106 rather than 03. These functions create very efficient processes as constant manipulations are not required during runtime. Only the comparison is required. The batch date, also referred to as the run date, defaults to the system date if not specified in the JCL. It can also be set to a specific value as JCL parameter in GenevaERS. The date is therefore consistent across all views in that execution of GenevaERS. This date can also be updated in the logic table build program GenevaERS. This is useful when VDPs are managed like source code and only created when changes are made to views. In this case, the VDP will contain a date for when the VDP was created. These dates can be updated in the logic table for the current date by running GenevaERS in the batch flow and use of the GenevaERS parameter. Because processing schedules may provide inconsistent results in rerun situations or when processing near midnight, some installations have written small programs which access an enterprise processing table containing a processing date to create this JCL parameter for use by GenevaERS or GenevaERS. At the end of a successful processing cycle, this same program then updates the processing date table with the next day's date. In addition to batch date, which returns a full date in the CCYYMMDD format, additional keywords provide access to a portion of the run date, from day, month, quarter, and year. Additionally, each of these keywords allows a numeric parameter which will add or subtract from the current batch date values for use in logic text. Other keywords allow for calculations and comparisons to the date. Days, months, and years between functions perform appropriate date math to return number of days, months, or years. The returned values can be used to evaluate logic text conditions or placed in columns. The fiscal keywords enable moving or sliding selection criteria using date criteria. For example, if a view should select data for a current month, the record filtering would need to be updated each month as the batch date value changes. Batch date returns the month value, for example, a 9, whereas fiscal month is a relative month, with 0 meaning the current month. Using the fiscal date and control record, the resolve constant in the logic table changes without requiring any changes to the view. For example, to select a date from the current month, use the logic text select if order date equals fiscal month plus 0. When this is executed with a fiscal date parameter of June, it results in a constant selecting June records. Without updating the view but changing the fiscal date parameter to October, results in selection of October records. As the fiscal date constant is updated each month, this effectively creates moving criteria for the current month. Attempting to use the batch month keyword would require changing the criteria from a value of 6 for June to 10 for October. Also note that the fiscal date parameter is useful when processing on a subsequent day, perhaps past midnight after business is closed for the prior day. The fiscal day can be set to the prior day or month, recognizing that the date is from the last day of the month, when the batch date reflects the processing of the actual run. The fiscal keywords returns date based upon fiscal values in the control record for the environment for a view. Each view specifies which control record should be used for its fiscal date processing. This means that different views in the same batch run can have different fiscal dates because they are associated with different control records. This is useful for processing views for multiple companies that have differing fiscal year ends. By comparison, run date is the same for all views in the batch. In this example, the view is assigned the fiscal date for control record ID 1. Other views processed at the same time may be associated with control record ID 2. Similar to run date, the actual fiscal date can be overridden in the JCL parameters. To do so, under the keyword fiscal date in the control record ID is followed by an equal sign and the override date to be used. Multiple dates for different control records can be listed. Fiscal dates can also be updated through GenevaERS parameter for VDP builds previously. If no fiscal date parameter is passed to either program, they default to the run date as the fiscal date for any fiscal day keywords. In this example, the fiscal date for control ID record is set to 2010-12-01. Note that the run date or batch date is set to June 1st, 2010. Next, we'll show the logic table containing a resolved fiscal date keyword. In this example, we use the fiscal month keyword, which requires a field in date form with a CCYYMM content code. Our selection logic is select if order date CCYYMM equals fiscal month minus 5. The run date will be set to 2010-06-01 and fiscal date to 2010-12-01. This should result in selecting records from 5 months ago relative to the fiscal date parameter passed to GenevaERS86, or records from fiscal month 2010-07. The view logic generates a CFEC function shown at the top with a constant of 2010-07 and trailing digits. Because the comparison is only 6 bytes, these trailing digits have no impact upon processing. The logic table trace below this shows this value in hex mode. In this run, all records failed this test. Note that if they had passed this selection logic, the lookup is effective dated. This can be seen in the LKDC, lookup key date constant function in the logic table. Note also that this lookup uses the run date 2010-06, not the fiscal date or the adjusted fiscal date of the logic table. This may produce inconsistent results between selection logic and date effective join. Care must be taken in creating views to be sure parameters are consistent. Viewing the generated logic table can help spot these types of inconsistencies. Like batch date, additional keywords provide access to portions of fiscal date including day, month, period, quarter, and year. These parameters all operate against the fiscal date parameter and can be used in logic text in the views. Each modifies constant in the logic table to perform the function. They also allow numeric parameters to perform calendar math either forwards or backwards. Other logic table functions also manipulate logic table in a particular way. The string keywords of all and repeat replicate constant parameters in logic text into constants in the logic table comparison functions. The isFound and isNotFound functions can change the logic table goto true and false rows for lookups. Other keywords generated specific logic table functions, like the isSpaces, which generates a CSL logic table function. These logic table functions are much less common, but might be seen in logic tables. They perform functions such as declaring accumulator variables, setting those accumulators to values, using them in comparison and extracting them, and performing math or functions against them. Also, logic table functions which work against the prior record might be seen, or range comparison or string searches. Also, if the logic text keyword begins with is used, Saffer changes the length of the field tested to the length of the constant in the logic text. This may result in something like a standard CFEC compare field event file field to a constant in the logic table with an adjusted field length. In this module, we examined the WRSU logic table function, which writes summarized extract to records. Other less common functions were also introduced. This module described extract time summarization and other logic text keyword functions. Now that you've completed this module, you should be able to describe uses for extract phase record aggregation, or ETS, read a logic table and trace with ETS views, describe how other Saffer functions affect the logic table, explain the function code used in the example, and debug ETS and other function views. Additional information about Saffer is available at the web addresses shown here. This concludes Module 18, Extract Time Summarization and Other Functions.